Satellite. Earth is satellite or planet?
Planet.
Planet.
अभी डिपेंड करता है, अगर मैं सन के लिए पूछूं तो ये सन का सैटेलाइट है ना, मून का प्लेनेट है, बराबर?
Yes, sir.
तो मून इज सैटेलाइट ऑफ अर्थ. It keeps on revolving in an orbit around Earth, circular orbit. Is it lighter or heavier, Moon, as compared to Earth?
Lighter.
Lighter. So any lighter body which revolves under gravitational influence of heavier body. Any lighter body which revolves under gravitational influence of heavier body is called as satellite. What is satellite? Lighter body or heavier body?
Lighter body. Lighter body.
It revolves under whose influence?
Heavier bodies.
Heavy.
Heavier bodies, gravitational influence, right? Any lighter body which revolves under gravitational influence of Earth is called as satellite. Any lighter body which revolves under gravitational influence of Earth is called as satellite. See this Sunday's test. In this Sunday's test, hello.
Yes.
Yes, sir.
After 34, sums were the of different chapter. How could you solve that? Everybody attempted till 45. How? Katan, how you attempted?
Sir, I get to go to the closed answers.
Pardon? Close?
I mean, like, I thought those were the answers, so I marked them.
No, no. Without knowing anything, how can you mark answer? That means the same thing you might be doing in other chapters also. Whenever you don't know, you mark any answer. This is quite possible now.
No, sir, not in every chapter.
Avan, how you could manage? Yes, Avan?
I tried somehow.
Or the one which you didn't got directly, you mark the answer?
I mean, the closest or
No, no. Please, please, please,
yes.
you all don't do that. If you don't know, leave it blank rather than marking the answer. With that, you will come to know your mistakes. And suppose solutions is sent, you can cross check. Otherwise, you will feel that you got the mark, but that is not genuine mark. Huh? Because when I started doing the solution of that elasticity part, because scalar spectrum we have already done, then I found this were of chapter called mechanical property of fluids. So I thought if I have not taught how you could attempt till 45, and nobody informed, sir, after 35, these are the sums which we feel we have not done. So next time onwards, please don't make mistake from your side. Okay?
Yes, sir.
ठीक है, चलो लिखो अभी. ये हो गया ये satellite any lighter body which revolves under gravitational influence of Earth नहीं, heavier body देखो. Gravitational influence of heavier body is called as satellite. How many satellites are there in sky? Only moon? There is only one satellite, moon, in the sky?
No, sir.
No.
Even people on Earth, they have launched artificial satellite, correct?
Yeah.
Like Sputnik,
Yes, sir.
Apple, Apollo, Skylab. They are different satellites. Geosynchronous Light Vehicle Satellite, GSLV. So few satellites are natural and few are artificial. And artificial satellite we have to launch. Do you know अपना एक satellite अभी फूस के निकल गया? It was mission Mars, I think, na? Where people
Yes,
were watching
somewhere.
that. What was the name of that? Name of satellite?
Sir, Mangalyaan.
Mangalyaan. Yes, Mangalyaan. Mangalyaan. So those satellites which are man-made, they must be launched in the proper circular orbit. So next heading, right? Explain launching of satellite. Explain launching of satellite. Not launching, it is launching of satellite. Vaishnavi, can you hear me? Vaishnavi? Vaishnavi, you can hear me?
Yes, sir.
Paper when you will send? Next year?
Sir, today.
Today, yesterday you were just searching the answers, I think.
No, sir. Yesterday I have to watch 4 videos recording. That's why.
That I excuses you don't give me. There may be 10 recording, full night you should wake up. To achieve something, you have to sacrifice something. Explain launching of satellite. The satellite to be launched is carried at the tip of rocket. So when single stage rocket, that means one rocket, is used for launching satellite, then it reaches up to certain height and returns back. So when the satellite to be launched is projected with the help of single stage rocket, single stage मतलब एक ही, खाली vertical or horizontal जाएगा. Then satellite will reach up to certain height and return back. इसका fuel खत्म हो गया. If velocity of projection is increased, then satellite will reach larger height, but again return back. See, this is the Earth. We have to take it at height and make it revolve. खाली vertical होएगा तो वापस vertically downward गिरेगा ना. If velocity of projection is increased, then a stage is reached when satellite, then a stage is reached when satellite never returns back and wanders in space. That means single rocket, say if I take launching, then only satellite will cover vertical height. That's why if you have seen this launching in movie or in National Geographic channel, you might see that first it is fired vertically, then it goes up, उधर जाने के बाद एक separate हो जाता है. देखा है ऐसा मूवी में?
Yes, sir.
Yes. That means it is not single. There are many rockets attached. एक फायर वर्टिकल, फिर वो खत्म, फिर दूसरा फायर खत्म, लास्ट में देखो एकदम रुक जाता है वो लास्ट वाला. देखा है मूवीज में? फिर उसको एक डायरेक्शन देके वो लोग फायर करते हैं. बराबर? हेलो?
Yes, sir.
Yes, sir.
Yes, sir.
So can I say सिंगल स्टेज रॉकेट से काम नहीं चलेगा? अरे कट कर दो मेरा. Yes. Again I'm repeating. When a rocket to be launched is projected by single stage rocket, then it reaches up to certain height and returns back. if velocity of projection is increased, it reaches larger height but again returns back. If velocity of projection goes on increasing, then a stage is reached when it liberates itself from gravitational influence of earth and wanders in space. मतलब space में किधर भी घूमते रहते हैं. Thus, two-stage or multi-stage rocket is required for launching satellite. Now see what two-stage will do. In two-stage rocket, the satellite to be launched is placed at the tip of second stage rocket. When first stage is fired, then satellite reaches up to certain height. At this height, first stage rocket gets detached. These are computerized. Programming from the earth gets detached. At this height, second stage rocket is tilted horizontally with the help of jet and fins arrangement. Jet means small opening through which excessive force is applied on the wall of this rocket which is hanging. तो इसका वॉल पे इधर ऐसा फोर्स लगा लगा के इसको टर्न कर देते हो. फिर मतलब ब्लेड which can circulate the force in all direction. The blades. Now when second stage is fired with correct velocity, then the satellite revolves in circular orbit. Incorrect hoega, so there are few possibilities which we have to see after this. What are possibilities when horizontal velocity is not correct? Correct आया, so it will revolve, and that velocity is called orbital velocity or critical. Incorrect आया, तो गोल नहीं घूमेगा, क्या होएगा? We have to see. Okay, please start writing. In that writing also you'll start understanding the concept. Right? When a satellite to be launched when a satellite to be launched is projected by single stage rocket, then it reaches up to certain height and returns back. Reaches up to certain height and returns back. If velocity of projection is increased, then satellite reaches larger height and again returns back. And again returns back. Chalo, written till this?
Yes, sir.
Okay, I'm clearing this. Huh? Everybody is okay.
Yes, sir.
One more paragraph. If Kathan,
Yes, sir.
anything if you are not knowing, please keep on asking. Huh?
Yes, sir. Yes.
Because this I'm telling to all medical students because medical competition is difficult as compared to engineering.
Yes, sir.
With velocity of projection is further increased, then a stage is reached when satellite liberates itself from gravitational influence of Earth and wanders in the space. Thus, two-stage or multi-stage rocket is required for launching a satellite. Thus, two-stage or multi-stage rocket is required for launching a satellite. Yeah, done till this also?
Yes, sir.
Okay. So with one stage, we can't launch it. Therefore, we require two-stage or multi-stage. So next paragraph, right? In two-stage rocket, the satellite to be launched is carried at the tip of second stage rocket. Carried at the tip of second stage rocket. When first stage is fired, then satellite is reached up to certain height. Is reached up to certain height. At this height, the satellite, sorry, at this height, the first stage rocket gets detached and second stage is tilted and second stage is tilted in horizontal direction with the help of jets and fins arrangement. With the help of jets and fins arrangement. Now, when second stage is fired with correct velocity, now when second stage is fired with correct velocity, the satellite correct velocity, then the satellite revolves in a circular orbit. This explains launching of satellite. Complete till this. Yes, written?
Yes, sir.
Yeah. Just in your mind, you all read this much. Anywhere doubt, please ask, because it is total theory based.
Sir,
Ah.
sir, in multi-stage satellite,
Same thing happens, but at every stage, tilting takes place.
no, I was asking ki, means there are multiple parts for the fuel, no?
Yeah.
So when they fall apart, like after one after another,
So see, from the top, when something falls, na, it gets scattered in particles.
okay.
When,
So
when it is taken to height, means it is more than 10,000 kilometers.
matlab it will stay in the space only, no?
No, no, till it is in gravitational influence, it will not, na, it will come down.
Okay.
See, Earth's gravitational pull is up to certain distance.
Yes.
If it is crossing, then it will wander in the space.
Okay.
Otherwise, it will come down. That's why now in the space also there is tension of these particles colliding, because they keep on
Yes.
moving in any direction. Sometimes they can collide. Na? That collision
Yes.
produces large amount of destruction.
Yes.
In
Okay.
the actually communication electromagnetic waves आते हैं ना, तो उसको
Yes.
disturbance होता है बहुत बार.
Okay, sir. Understood.
Now this if you have done, then we'll see what will happen if the velocity is not correct. Can I clear this?
Yes, sir.
Okay. Next heading, right? What are the possibilities? What are the possibilities when satellite is projected horizontally from certain height? One possibility you saw, if it is correct velocity, it will perform motion in circular orbit. If not correct, there are few more possibilities, right, Eddie? First you write the heading because I require space for diagram. Then I'm clearing it. Written? चलो एक line लिखो. There are following possibilities when satellite is projected horizontally. There are following possibilities when satellite is projected horizontally. Case 1. Case 1 will write, then I'm clearing to draw the diagram. Case 1. If, see, this is satellite, this is Earth, this is velocity given. So actually it is tangential given to that body. That is called horizontal velocity. So if horizontal velocity, v suffix h is less than critical velocity. Critical means correct velocity. Critical velocity vc. Now because it is less, definitely it will not move in a circle. Hello?
Yes, sir.
If it is less, it is not moving in circle. Then what happens? Then the orbit of satellite, is an ellipse. Orbit of satellite is an ellipse with point of projection as चलो इतना लिख लो, वो पॉइंट का एक अच्छा सा नाम है. If horizontal velocity is less than critical velocity, then orbit of satellite is ellipse with point of projection as. Just write this much, then I'm writing what is that. If completed, please guide.
Yes, done.
Okay.
Sure.
With the point of projection as, special name is given to this, apogee. That means farthest from the earth. Then with diagram I am explaining. First you have to write. Apogee means it is far away from the earth. Apogee and earth as one of the foci. Now this is satellite and here I consider earth. So when you project this, then it will become ellipse with earth away from this focus. You see, this is ellipse. There are 2 points which are called focus. So earth is one of the focus. This becomes our point of projection. Point of projection is far away from the earth. There are 2 focus. One is this, other is this. So when you project here, then that focus which is earth is far away. That point is called apogee. अभी दूर है तो दूर वाले से लाने के लिए क्या बोलते हैं? apogee. गुजराती में आपो मने आपो, तो आपो किससे पूछेंगे? दूर वाले से बोलेंगे ना. तो आई हैव टू रिमेंबर लाइक दिस, apogee मतलब दूर में है. So this is suppose point of projection. 1 minute, huh? This is point of projection of satellite. It follows elliptical path with Earth as focus, which is far away from point of projection. Clear? Meaning followed?
Yes,
Yes,
sir.
sir.
That time that point of projection is called as what? Apogee. Apogee means Earth is away as a focus of that ellipse. This is case 1. So many times theoretical MCQ they can ask, if Earth is away, what is that position called? Apogee. Next you will find perigee. Perigee means it is closer. So that way there are 2 points: apogee, away, perigee, closer. Can I clear this now?
Yes, sir.
Okay. First case, if critical velocity say come, then it will follow elliptical orbit where point of projection is far away from Earth as focus. Position is called apogee. Case 2. Case 2. All diagram I will show you at the end. Case 2. If velocity of projection VH is equal to the critical velocity VC, then satellite revolves in a circular orbit, right? So when it is projected with correct velocity, satellite revolves in circular orbit around Earth, right? Second case. Shall I clear this?
Yes, sir.
So one velocity was less, other velocity was equal. Case 3, when horizontal velocity of projection VH is less than escape velocity but greater than critical velocity, then again satellite revolves in an elliptical orbit, but the satellite again revolves in elliptical orbit, but the point of projection is closest to Earth, called as perigee. This position is called perigee, point closest to the Earth. That means Earth is situated here This is point of projection. This way it will be ellipse. Earth becomes closer. पहले वाले में this was that ellipse where Earth is away. ऐसा था तो. Right, case 3. Then I'm showing the diagram of all the cases separately. When horizontal velocity of projection is less than escape but greater than critical, again satellite revolves in elliptical orbit, but point of projection is closest to the Earth, called as perigee. Hello? हाँ. हाँ. नहीं, रुको 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 रुको. मेजरमेंट और इलास्टिसिटी जो आपने भेजा था ना, वो किसके लिए था? दिस टाइम आपने भेजा था मेजरमेंट्स के लिए था क्या? दो पेपर था ना कि एक ही था? हाँ, तो शायद गलती से हो गया रहेगा फिर. तो जो भी स्केल नहीं स्केलर स्पेक्ट्र और इलास्टिसिटी है वही भेजो. हाँ, किसका ऐसा आया? नाम है क्या उधर? इस पे जनरली मैं ना सब एक साथ नहीं भेजता हूँ, क्योंकि क्या वो उसमें सब एक आगे पीछे हो. आयमन, हाँ, तो उसने क्या दिए भेजा है? नहीं, जिसका भी रहेगा ना ऐसा स्केलर स्पेक्ट्र नाम दिखता तो आप मुझे एक बार बाद में लिख दो ना. निजा महाजन, उसने क्या भेजा है? मेजरमेंट और स्केलर स्पेक्ट्र है. अच्छा, गलती से आ गया रहेगा फिर. क्या वो संडे देखा रहेगा? इस संडे वो लोग ने भेजा नहीं होगा पेपर फिर, और खाली संडे देख के मैंने भेज दिया रहेगा. दो ही होगा ना फिर. तीसरा कौन सा है? ठीक है, चलो ये दो तो समझ गया मैं. ये दो निकाल दो, फिर बाद में फिर से भेज. वो उधर से निकाल दो फिर वो. हेलो, कंप्लीटेड?
Yes, sir.
Fourth one. So first possibility less, second equal to critical, third greater than critical but less than escape. Now, fourth one, case 4. When the horizontal velocity of projection BH is equal to escape velocity. Equal to escape velocity, then the satellite follows parabolic path and never returns back to the point of projection. मतलब वो escapes कर लेता है. इधर से थ्रो किया तो it goes parabolic path and wanders in the space, never returns back to the point of projection. Its speed is zero at infinity. Why zero? That I will explain while explaining you what is escape velocity. Okay, case 4. One more case is there, then launching of satellite का possibility खत्म.
Sir,
हाँ.
I have a doubt.
Hmm.
Sir, the escape velocity only is needed only when it's projected, no, from the Earth. So does it matters for the horizontal velocity of projection in case that?
No, see, this is where you are going to project at certain height.
Yeah.
Now you don't know that velocity, whether it will become perfect or it will become imperfect.
Yeah.
If this velocity becomes equal to escape, then satellite will not revolve, but follows parabolic path ऐसा आके and goes to the space में ऐसा इधर से आके ऐसा space में चला जाता है.
अच्छा, okay.
This that part.
हाँ, समझा.
That's it.
Yes, sir.
हाँ, अगर रिवॉल्व होता तो इधर से वापस पास होता ना ऐसा. Okay. Copy case 4. That's why I say every launching is not successful. For success, it requires that circular orbit. Completed fourth, one last point now.
Yes, sir, done.
Okay. Case 5, last case. If horizontal velocity of projection VH is greater than escape velocity VE, then satellite follows hyperbolic path and liberates itself from gravitational influence of Earth. Right, fourth case, fifth case. This time it is not parabolic but hyperbolic path. Shall I clear?
Sir, just a minute.
Because after this, that five possibility ka diagram and then critical velocity ka derivation has to complete, minimum that. This Sunday stress you all are knowing now what is the topic?
Yes, sir.
Law of motion and theory of gravity, whatever we did.
Done, sir.
Sometimes they can ask, draw the diagram showing the possibilities of satellite projected horizontally. So this possibility, this is Earth. At certain height, we have satellite being projected. So first, if it is less than critical velocity, then it will follow elliptical path this way. This is first case, where horizontal velocity is less than critical. Okay, draw this first case, first diagram. VH, first possibility, VH is less than VC. If VH equals to VC, then it will follow circular orbit. Circular means Earth will be at center. This is second possibility. VH is equal to VC. Third possibility, it follows elliptical path with Earth being close to the point of projection. So your VH is greater than critical but less than escape. Less than escape but greater than critical. This is parabolic path where VH is equal to escape. Last one, VH is greater than escape. This is called hyperbolic path. So total there are 5 cases. 1, 2, 3, 4, 5 keys. First case, Earth becomes away. So this is that ellipse. Second case, circular orbit. Third case, Earth becomes closer. Fourth case, parabola. Fifth case, hyperbola.
Done, sir.
Shall I clear the diagram? Yeah, can I clear the diagram?
Yes, sir.
Define critical velocity. Define critical velocity. Was it horizontal velocity or vertical velocity? This critical. ये अर्थ था, ये सैटेलाइट है, इसको हॉरिजॉन्टल पुश किया ना, so that it performs in a circle. So critical velocity is nothing but horizontal force. The horizontal velocity with which a satellite at certain height, the horizontal velocity with which a satellite at certain height above Earth's surface must be projected so that it revolves in a circular orbit is called as critical velocity. the horizontal velocity with which a satellite at certain height above Earth's surface must be projected so that it revolves in a circular orbit is called as critical velocity. Yeah, write down.
Done, sir.
Derive expression for critical velocity. Derive expression for critical velocity. So first we have to consider a satellite of mass m at height h above Earth's surface, whose mass is m, radius capital R, to be projected horizontally with critical velocity vc so that it revolves in a circular orbit around Earth. Radius of orbit is small r equals to r plus h. Again, I'm repeating. Consider a satellite of mass small m at height h above Earth's surface. Consider satellite of mass m at height h above Earth's surface of mass capital M, radius capital R, to be projected horizontally with critical velocity vc so that it revolves in a circular orbit of radius small r equals to r plus h. Any doubt in this?
No,
Hello?
sir.
Yeah. Please draw the diagram and write this much. देखो आयमन का जो पेपर है ना वो 2 पेज में है देखो। हाँ वो बराबर है, वो इसी बार का है, भले उसने आंसर जो भी लिखा है। नहीं उसका भी देखो, वो इसी बार का है, शिला सत्र और इसका ही है। फिर अभी निजा का चेक करता हूँ पेपर। Completed?
Yes, sir.
So far we have only described the variables used. M is mass of satellite at height h above Earth's surface, having mass m, radius capital R, projected horizontally with critical velocity vc, so that it revolves in circular orbit of radius small r equals to r plus h. Now, as the satellite performs uniform circular motion, short form में UCM, performs uniform circular motion, hence it requires centripetal force. We have done this chapter, circular motion. Centripetal force provided by gravitational force of attraction. Therefore, centripetal force is gravitational force of attraction equals to gravitational force. Gravitational force is G m upon small r square. Centripetal force is m vc square by r. Centripetal force formula mv square by r we have proved earlier in chapter called circular motion. So centripetal force is mv square by r. Gravitational force is gmm by r square. Mm cancel, one r cancel. We get vc equals to root of gm by small r. This is expression for critical speed. This is expression for critical velocity. Okay, clear this also? As satellite is performing UCM, it requires centripetal force provided by gravitational force. Centripetal force is mv square by r. Here v is vc, and gravitational force is gmm upon r square. So vc is root of gm by small r. This is expression for critical velocity. Everybody has followed?
Yes, sir.
Yes, sir.
Copy till end. In 2 lectures, theory of this chapter will get over.
Done, sir.
Now, can you tell me with this formula? Just I'm writing something on the board. Same formula I'm writing, and one query is mine, which you have to explain. Gm by capital small r. So if I take satellite of 1 kg, 10 kg, 1000 kg, 10,000 kg, which will be more easier to launch? और किसमें critical velocity कम लगेगा? 1 kg वाला सैटेलाइट क्या 10 क्या 1000 क्या 10⁴? किसका क्रिटिकल वेलोसिटी कम होएगा, ज्यादा होएगा? ऐसा कुछ है? सब में सेम रहेगा. It is
Yes.
independent of mass. So sometimes they can ask, it depends upon which factor. So or it is not dependent on which. So एक लाइन लिख दो. It is independent of mass of satellite. It is independent of mass of satellite. Done now? It is independent of mass of satellite. Hello?
Yes, sir. Done.
Yes, sir.
Law of motion, I have told you, please practice.
1 to 70.
1 to 70. Any doubt is there in 1 to 70?
No, sir.
No,
Pakka?
sir.
So this Friday, can you complete from 71 to 150? Today is Wednesday, Thursday in 2 days.
Yes, sir.
Yeah. Complete till 150. That day, if any doubt is there, first I will solve that, then proceed ahead. So your homework is this plus whatever we are doing in gravitation chapter theory. Friday's theory I will not keep in gravitation chapter. So whatever I have done till Wednesday, theory on that much. And MCQ 1 to 200 का बीच में से any I can ask you from our sheet only. Okay, everybody's understood test का syllabus.
Yes, sir.
Till
Yes,
today,
sir.
whatever I have done in theory of gravitation, and 1 to 200 MCQ में से any 45. So now it is almost you know your paper. Only the thing you have to practice all. So that's all for today. Let's meet on Friday. Now anybody is going out for 31st?